Hello friends, today we will discuss the most important fact about the radius of convergence. Now let us define the radius of convergence is that the series of this sigma cn z to power n be 1, r is equals to 1, and let the series terms are decreasing and n tending to infinity, cn term is 0, the nth term is 0. We will say that nth term is 0, but the radius of convergence is 1, because while the r is equals to 1 over rho is supremum of limit n tending to infinity an to the power 1 over n, right? Because this is the nth term, limit is 0. This is not the whole sequence supremum's limit n tending to infinity. Okay, so there is the difference between the nth term limit is 0 and the r is and then if it is supremum of this, it is 0, then r is equals to infinity, right? So if we have the radius of convergence of this series is 1 and the terms are decreasing and the term is 0, so the series converges at each point of the circle mod of z equals to 1, but not on z equals to 1. That means that it converges to whole region of this circle z equals to 1, but not at the point z equals to 1, this boundary point, right? This boundary, at this boundary it is not converging. Now let us prove it. Let an is equals to z to the power n and bn is equals to cn. An is z to the power n, bn and the terms of the sequence series. Now mod of Sn is sigma ak, which is the series term, sigma zk. When the sigma zk, then it means that z1 plus z0 plus z1 plus z2, this is geometric series type, right? Which of nth term, so then it is becomes 1 minus z to the power n plus 1 upon 1 minus z, which is bounded by z over 1 minus z for n tending to infinity. Since the radius of convergence is 1, so the circle is bounded by 1, and for what 1 at z equals to 1, it will the denominator becomes 0. If z equals to 1, when we put, then 1 minus 1 is equals to 0. This will gives infinite. So at z equals to 1, it does not define. So we will take mod of z 1 minus z is greater than to 0, right? On z equals to 1, we will take mod of z 1 minus z is greater than to 0. That is the point for this term to be exist. Okay, therefore the sequence Sn mod of Sn, okay, is bounded on the circle where the mod of z is not equals to 1. The Sn is bounded by the term, that type of terms where mod of z equals to 1, it is not equals to 1. When it is equals to 1, then it will become 0. So this Sn is not defined. Sn is not defined at z equals to 1, right? So it is bounded, Sn is bounded on the circle z is not equals to 0. Mod of z is not equals to 0. Hence at z is not equals to 0, it satisfies all the Dirichlet test requirement. So series is convergent at each point of the unit circle mod of z equals to 1, except the point z equals to 1 at the boundary point.